Today's talk is basically it's Hadoop Hadoop demo. And just give me just little introduction about myself. My name is Venkat. I do have around 15 plus years of IT experience. I worked in very big organizations like Microsoft India as a permanent employee. I worked with previously Citigroup London and Citigroup Frankfurt and worked in Barclays, Singapore. Yeah, and currently working as data warehousing, big data projects as a solution architect. That's about me. I think let's get started. Yeah, the features of this Hadoop course is basically I will be the instructor for the entire course, so no need to mention I have a real-time experience. And number two is basically it's an instructor-led online training. Probably unlike other online courses, here we will give an opportunities for the trainers, for the trainees or the students to ask questions. Probably it's basically instructor-led online interactive training. So if students have any questions, they can raise their hands. We will give a chance to talk, and ask their questions. At the end of the each module, we have Q&A. Probably that helps to understand whatever the topics covered in that module. And the lab, basically, we will give a VM, Apache Hadoop VM. So probably you can practice in your own laptops, and we will give support if you have any questions, if you have any queries. Probably we'll do support over Skype. And we will take the feedback after every class and we try to address all the problems whatever the students have, and that's the other thing. And YouTube practical videos, what we have done is based on our experience in previous classes. We have recorded whatever the practicals we are covering in the class, and we got a very feedback from our previous students because they can go through these videos at later point of time and they can go through it multiple times to understand again some of the practical sessions. That's definitely helpful, and at the moment it's public. Probably we're trying to change it to a private, so probably we'll give access to these videos only for our students. We will provide a source code for all the practicals we have covered in the class. It's a working source code with all the form.xml, all the entries, unlike just giving the source code. Now this all compiled codes with form entries. It should work without doing any changes. And we will give you the course material as well. Probably this is our first class. Similarly, we have around 12 sessions and we have material for 12 different this thing. So probably we'll share all the material. And the project, we will talk about different use cases, in what all scenarios we'll use Hadoop and Hadoop project as well. Yeah, this is basically our course features. And we will give also classroom trainings as well, apart from this online training. And course contents is basically, this is what we'll cover in the course. So the overview of Hadoop and big data, Hadoop architecture, and HDFS MapReduce, advanced MapReduce, and other ecosystem components in Hadoop like Hadoop, Big, Hive, and HBase, NoSQL database for Hadoop, and some advanced HBase Hive integrations, and Flume, Scoop, Uzi, and and almost before the closing the our course, we will talk about XML processing as well, MapReduce XML processing, because XML is one of the primarily used format for exchanging data across applications. So we will talk in detail about XML processing as well, and we go to Cloudera VM and Spark streaming and SQL, Spark SQL and Spark streaming and Impala, and we will cover the installation of all Hadoop ecosystem components, Hadoop, Pig, Hive, HBase, Scoop, Flume, everything. And at the end, probably use cases for Geek projects and the project. And even this course, designed in such a way that we will do a lot of practicals. Probably, in case of MapReduce, probably we'll go at a very lower level, like creating your own custom input formats, custom uh, data types, custom key, custom values. So probably we'll go at a very low level, end-to-end concept of MapReduce with the practical examples. Probably that is probably this differs from I think other uh, courses in the market. Yeah, I mean, so before we get started with Hadoop Dev, so let's talk about what are big data technologies. Within big data technologies, probably start with Hadoop development. We have other technologies like Hadoop admin, Apache Spark. It's basically the streaming for data, streaming data. This is probably it's in memory processing of the streaming data. In Spark, we have both Spark streaming. Yeah, I mean, yeah, big data technologies. I think Apache Spark. Um, we have both for streaming as well as Spark SQL, Apache Kafka. It's more like MQ series from IBM, MSMQ from Microsoft. It's message-oriented middleware within Hadoop. This thing, Apache Kafka. MongoDB is NoSQL document-based database, and Cassandra is again column-oriented database. NoSQL column-oriented database. Talent and Informatica, these are ETL tools, and they have support for big data ingestion as well. This is about big data technologies. So our course is basically Hadoop development. And the topics for the first class, before we start talking about Hadoop, we'll discuss why Hadoop is required in the first place. So we'll talk about a bit of history and what is a big data and how Hadoop addresses big data problems faced with probably traditional data warehousing applications. And we'll talk about Hadoop distributed file system, how data is stored in Hadoop and how the processing will happen against the data stored in HDFS, and what all different ecosystem components within Hadoop framework and Hadoop jobs market, how the market outside for Hadoop, and at the end, question and answers. Yeah, I mean, let's get started with the actual talk about the history to understand why Hadoop is required in the first place. Um, and one more thing, here we will do this in two parts, Hadoop demo. And part one is basically we'll talk about why Hadoop is required in the first place. Right? And part two, we will talk about the Hadoop, actual Hadoop. Hadoop we'll talk about HDFS and MapReduce. Yeah, I mean, I think it's worth to know before we start going to Hadoop why Hadoop is required in the first place. So probably this is what different from I think other courses. I think we are spending significant amount of time to understand why Hadoop is required in the first place and what are the limitations of um, traditional data warehousing applications. So let's start with part one. Probably we'll talk about history and all to understand why Hadoop is required. Yeah, and probably at the end of this we'll understand what is operational reporting and analytical reporting. We'll talk about in detail. Probably very beginning, probably around 93, 94. Now what you have is a standalone applications. Standalone application is basically what you have is a single machine which has both a database as well as kind of a GUI for entering the data and even for viewing the reports, and even the data is stored in a same standalone application, standalone machine, even the database. So example for standalone applications is like MS Access, Fox Pro. You see MS Access, most of them might have worked in MS Access. Probably there are still some legacy application where there are probably very few. Probably if you are probably more than 10 years plus experience, I think you might get a chance to see MS Access based applications. Yeah, as I mentioned, MS Access, we have MS Access forms. We'll enter the data and reports for viewing the reports, and even the data is also stored in the same machine. So everything is stored in the same machine. So probably it's not in the network. So when you enter the data, probably take an example. Let's say we have Domino's, right? Domino's, we have branches across different places within a city. Probably it has a, let's say, branch one, branch two in different locations. So probably when you go to branch one, when you are the first time visitor, they will ask for your username, whatever, name and phone number. So probably they enter all the information. Probably when you go to different store within the same city, so they don't have your information, because whatever the information you have given earlier, that is stored only in their specific database. So it's not accessible to the store outside, even within the same city. So that's basically a standalone applications. So after that, then they started with something like client server applications, and these are very popular. I think around 93, 94, around 93, 94. What they have done is they moved the data into a centralized database. Here, if you see the server, this is basically a server where you have the centralized database. And very popular client server applications are developed in Visual Basic and bit of Java as well. And the databases are MS SQL Server and Oracle. And these are very popular databases for client server applications. So now what they have done is the client can be located anywhere, probably even across the country in different cities and different branches within the same city. But whatever the information they will enter, the key in, all the information is stored in a centralized server, which is a database server. So probably when you talk about the same thing, probably let's say talk about a bank, right? When you go to a bank, probably in one of the branch, in let's say in a city in India, we have many branches for a specific bank. First time, so I mean, whatever your information, whatever the your information is stored in a centralized location. So let's say you have your account in city one and bank one. Even if you go to city two, also your information is there because data is stored in a centralized location. And this is basically client server applications. So your data is stored in a centralized storage, and even if you go to different city also, your information is accessible because data is stored in a centralized server. And probably even around same time, even browser based applications also has come evolved around the same time, 94, 95, 93 times. The major disadvantage of client server application is whenever you do any changes to your application, we have to deploy your application in each and every client machine, right? Even if problem in installation in a specific machine, user not able to access the application. So let's say we have 200 users for a specific application. I think it's a very tedious job when you are doing the deployment to ensure that deployment is successful for each and every user, and even you also have to ensure that the client is using the latest version. Even he might be start using the old version as well. uh, because even after we have done our releases, when the request is coming from the client, you also have to check whether the client is using the latest versions. And deployment is probably a very tedious job in case of client server, because we have to install in each and every machine. So, I mean, yeah, around same time, what you have is called a browser-based application, which are getting popular. Right? It's clear. I think standalone client server, and move on to one more kind of applications called browser-based applications. It's more or less similar to client server, but what they have done, they have added one more tier called a three-tier applications. We have a client here. Yeah. And client is here basically a browser. It's a thin client browser. And the request will go to something like web server, all you are aware. Um, Again, storage is the same. Storage is basically DB server. Only difference compared to client server application is rather than client directly talking to the DB server, there is a web server, and web server will talk to the database. So the advantage is, I think, uh, the biggest problem in client server application is deployment. Now we need not deploy in each and every client machine because there are many clients. We have client 1, client 2, client 3, any number of clients. So our deployment is only in one web server, and the client is just a browser, and the problem of deployment is solved in case of three-tier applications. It's basically called three-tier applications. Yeah. Yeah, and basically, here in client server application, these web-based applications, some of the web applications, we will enter the data. These kind of applications are called OLTP applications, online transaction processing, OLTP applications. Of course, there are reporting applications as well, but some of the applications most are OLTP applications, online transaction processing. OLTP applications are designed for better inserts and updates. Now, example is, let's say when you go to Flipkart, when you go to Amazon, right? We will enter the data. So data is getting created from these OLTP applications, right? And these are basically called OLTP applications. and we need to see some consistent data. So that's why, because we have transactions, we can run commit run transaction support. This usually the database is relational databases. We will design our database for better inserts and updates. Right? That's basically about that's basically about these applications, standalone applications where data is stored, everything in a single machine, and client-server applications where data is moved to centralized location, and web-based applications where you have one more tier, and it's a client talking to web server, uh, and it's talked to the database. And yeah, I mean, as I mentioned already, some of the applications are OLTP applications where data is getting created. Example, Amazon or point of sale. Let's say when you go to a retail store, when they do the billing, right, that's where data is getting created. And these kind of applications are called online transaction processing, already discussed, and they have their own reporting as well, which is basically called operational reporting. But let me take a simple example to make it clear here. Let's take one of the big corporates. Let's take an example of Reliance. They do business in different line of business, right? And let me do this like this. Now they are into different businesses. Basically, they are into yeah, they are doing different business. Basically, let's say oil and gas. They are into retail, and they are also into recently into telecom as well. They are not yet launched, but they will launch soon. Yeah, probably for this example, we will take the retail, which is pretty easy. Let's say in retail, um, within a city, they have many stores. Right? Let's take an example. Let's see. Let's say just want to make it simple one. Store one. Store three. Yeah. As I mentioned, probably we'll go to store, a specific retail store, and when you purchase groceries, right, whatever items, that is where point of sale, where the data is getting created, right? And similarly, we have different stores, and there are probably everybody, within city there are many stores. Now there will be consumers who go and buy groceries. Right? So let's take an example of the store one supervisor. Right? Store one supervisor is not interested basically what is happening in different stores within a city. Let's say all these store, one store, two store, to a specific city, right? Is more concerned about the sales within the store one, right? And this is basically called an operational reporting. Whatever I mentioned, standalone application, client server applications, and feeder applications, and they do their own reporting, that is basically operational reporting. Example, store one supervisor is interested on what is the inventory of a specific product, right? And what are the items he has sold in a specific date, and what is the amount returned back by selling these products. And he will go to the each and every transaction, each and every order item, and ensure that the price for the product is correct. And at the end of the day, he will reconcile that what all the items sold, whether he has got money back for the items sold. And apart from that, he will also look into the inventory. So don't want to out of stock any product. So, and store one supervisor is interested in these information, right? How many items sold, whether they got the money back, and the inventory information. And this is called an operational reporting, right? Every system has its own operational reporting, but usually they don't keep the history of the data, right? It's clear. Then that's basically operational reporting. We will go at the record level, right? And let's say we have Reliance, right? We're talking about retail. We have retail head. Probably someone is heading the retail division, right? Retail head of retails, and probably head of Reliance. Yeah, Mukesh Ambani, okay, right? And even Mukesh Ambani also, we see some reports to understand how his firm is doing, right? And unlike the store one supervisor, he is not interested in looking into reports, how many items are sold, whether I have inventory in my store. I mean, he is not interested in those information. What he is interested is probably what is the market share of Reliance retail. And across India, they have different stores. Right? They have stores in Pune, Hyderabad, across India. So, which store is doing better compared to other store? What is the store which is doing maximum business, and which city is performing better compared to other cities? And retail head and probably head of Reliance are interested in this kind of reporting to take decisions, decisions to improve their market share, decision to improve their sales, and this is so to take decisions. That is what they need for reporting. Now, how Pune is doing compared to Hyderabad, where to open the next store. Now, what is the trend? What are the revenues of a specific city last year compared to this year? What's the trend in last 1 year? Now, this kind of reporting they are more interested on for taking decisions where to open the next store and how to improve their market share. And this is called basically analytical reporting. Right? And data warehousing applications basically are designed, just to move on to data warehousing applications, is designed for a decision making. Right? Again, let's take an example, a simple example. Right? And we need a kind of data warehousing applications as well. It will talk about why this is required, right, for analytical reporting. Right? Let's take a simple example. Right? Let's probably this time we will take little bit. We'll take an example of a corporate or a bank which has operations across the globe, right? And they do a different business. Let's take an example of Citigroup. Let's say talk about Citigroup. And Citigroup, they do business in different asset classes. Basic asset class is kind of a product, right? City Investment Bank, they are into FX. FX is foreign exchange. If you want to buy a dollar and sell rupee, right? When you go and ask for a dollar, basically what you're doing is you're selling rupee and buying US dollar. So, and they also do equity business where we buy shares and sell shares to an exchange. So, so they do a different business. Each asset class has its own database. Right? Let me take an example here. Right? Let's say they are doing FX. I want to make it simple, not more. Equities. I think it's clear what is equities. And we'll take another example like uh, uh, fixed income. Fixed income is kind of a bonds, what you buy. We'll always get a fixed income with no risk. Let's say when they sell the bond, they say we will get yearly interest of 8%. Right? So that's another kind of asset class, right? Let's say each asset class has its own database. Right? I think every system has its own database, right? Now, let's say we have what head of marketing, right? And his requirement is basically head of marketing. He wants to see FX, equities, and fixed income sales together, right? I want how FX is doing compared to equities, how fixed income business is doing compared to FX, right? So if the requirement is to see reporting for a single source which has all the data FX equities fixed income, right? This is nothing is not there before the data warehousing applications. So that's the need for data warehousing application. Let's say before data warehousing and data mart applications are there, someone sitting here, right? Some basically is at office, right? Probably finance, let's say we call it finance team, whatever, right? If at all they have to create reports across 3 different systems, right? Let me make it clear here. It's a it's a DB1, DB2, DB3. So it has its own database, and there are 3 different systems. So someone in the finance team, they have to go back to each and every team, FX team, equities team, fixed income team, and they have to ask for information, give your sales for the last 3 months, whatever, if at all you want to see out of marketing last 3 months across different asset classes. You ask for FX, and again, different team to get the equities and fixed income, get the information, and collate the report with all the information provided by FX team, equities team, fixed income, which is very tedious job. So that is why they've come up with data warehousing applications, a single version of truth rather than creating the reports from 3 different systems manually, getting the information, put into Excel, and creating manually compiling the report, which is a very tedious job by someone in the finance team. So they have started developing a data warehouse or data mart applications. data warehousing application, enterprise database, it's not practically possible based on my experience. So usually they will build a data mart or a data warehouse for a probably specific team for marketing, sales, finance, or three teams together, right? So yeah, probably in our case, if we want FX equities, fixed income together, they want to see for a marketing, sales, and finance team. So we will build a data mart for these teams together, finance, marketing, sales, and we will now you integrate the data from different systems now, right? Which is a tedious job. So what to do is we integrate the data. Sorry. And we will yeah, and from a different upstream systems we will integrate the data and we will do the reporting from the centralized data node which has data for all the asset classes, FX, equities, fixed income. Here probably we'll talk about more it depends, we have dimensional data modeling. I don't want to talk in detail dimension data modeling, facts and dimension, because this system is designed for what reports. So the system is designed for reporting. Let me put this objective is for reporting with better response time. So we will design these tables in a dimensional data model. Now we will use dimensional data model. It's a denormalized tables which reduces the joins and it improves the read performance. And you can create the cubes as well. Yeah, and for again for better response time. And these systems are basically OLTP systems. All these systems are called OLTP systems and usually designed as a relational databases. Yeah. So that's the need for data warehousing or data mart applications. So now we will do the reporting. Let's say I'm the client sitting here. Yeah, create reports out of here. Right? We have cubes. We can create so many other things um, for self-service reporting and all. So now, basically, the goal is create from a centralized storage which has a history. Now we'll keep history of data, and so trends and all. You probably can create reports for probably 5 years worth of data, whatever. Usually, in case of OLT applications, we will purge the data at any point of time. We'll keep it only 1 year worth of data because operational reporting needs doesn't ask for historic data, but here it does ask for historic data for decision making. Right? Yeah, that's basically the need of data mart or data warehousing applications. Yeah, and probably here, just want to give a little bit information here as well. And here we will use ETL tools for data integration. The most popular one is Informatica, Data Strays, SSIS, so on and so forth. And we will use these tools to integrate the data from source systems or operational systems into a data. And that's why the need for data mart is basically we do analytical reporting. This is for a decision making. Now, right, this person, head of marketing, he wants to see that there could be many sources, probably 40, 50 sources, depending upon the size of the application. When you work in probably now, when you get a chance to work in big banks in reporting application, you might have to get the data from 30, 40 sources as well. So, I mean, and we do reporting from a centralized repository or data mart. And this is for analytical reporting for decision making. Right? So, for analytical reporting, we will use data warehouse applications. Let's now move on to what are there are limitations with these applications. Right? What's happening is now the organizations are start capturing more data now, which was not captured earlier. They keep capturing more data, and data also keep growing. Let's say initially when start application, we might be getting only 1 million records. When the business is growing, from this source FX, we might be getting 5 million records. From equities, also probably increased from 5 million to 6 million. So when the data is keep growing, our data mart systems or data warehousing systems are not able to process the data no, and we are missing the SLAs. So probably we'll talk about that at a high level and then to understand what the limitations of these data warehouse applications. Let me have one more this thing. Yeah, I mean, let me take this. Let me take it. Let me partially save this. Right, let's say we have all the systems. Let's say when you started the application, we have, let's say, take a simple example. We have three sources. And one more thing, like City, right? They have operations across the globe. Well, let's talk about the requirements, right? Let's say our requirement is so our requirement is T+1 reporting. Let's say when trade is done, One trade is done on 15th September 2015, right? Let's say need to report on 16th September. Right? That is requirement because here what during the day data will be keep inserting from here. Usually, we I mean let's say assume here our requirement is only T+1 reporting. We don't need to report the data real time. So, and at the end of their day, they will give their feed file and probably will report the next day. Right? So, the trade is done on 15th September here. We have to report the data on 16th September. Right? 16th September at line 9 a.m. Let's take 9 a.m. London time. Right? Which is close to just probably it's 1:30 or 2:30, 1:30 p.m. IST depends on daylight saving. Let's assume that is 1:30 p.m. IST. The requirement is when the trade is done on 15th September, we should report the data on 16th September at 1:30 p.m. IST. Right? And here so city has operations in Sydney. Sydney. They have operations probably at a major zones, right? Sydney, Singapore, London, and New York. So let's say 15 September 2015. Right? And it starts in Sydney, 15 September 2015. But when you reach around 15 September, at let's say 6 p.m. in New York. Let's say the closing around 6 p.m. because even in US also different time zones. Probably it will go until 7 p.m. as well because California and all probably work late because the different time zones within the US. Usually stock markets are closed around 4 o'clock, but still it's open for other reasons like California and all. So and so unlike probably what our, let's say, Reliance store in India, where it operates from 11 a.m. usually to 10 p.m., here, when you have operations across the globe, right, we will start 15 September around 9 a.m. in Sydney, and uh, and data will be keep generating from these OLTP systems until 15 September 2015 at 7 p.m. Right? So basically it's 7 p.m. If you convert into India time also, right? We are reaching 16th September around 2015 7 a.m. We already reached the 7 a.m. time, right? So once they have completed there is no more data getting generated because for 15th September, probably again it starts probably 15th September around 7 p.m. You almost starting the operations in Sydney again. Now probably we'll already 16th September again. We will be start trading for 16th September, right? Right. So at least for the 15th September, right, data is closed around 7 p.m. New York time, which is 7 a.m. 7 a.m. IST, right? But the thing is, now after they closed their day and they have to do their reconciliation their side and probably end of day checks whatever in the operational systems, that will take around 2 more hours, right? Could be 3 hours as well, so 2 hours, let's say. End of the day checks, right? So ready by 9 a.m. IST, right? So your data for 15th September will be available by 16th September around 9 a.m. IST time, right? So, and our requirement is we have to process all these data, whatever data integration, this data integration using ETL tools, data cleansing, data transformations, and if at all converting to dimensional model, we have a cubes, populate the data in the cubes. Now all these things has to be finished within, right, around 5 hours, because 9 a.m. it will be ready. Within 1:30 p.m. we should make the data available for reporting. This is SLA. So we have only 5 hours of time to complete the data integration, data cleansing, all this data integration, data cleansing, data transformations, everything you have to complete by 5 hours, right? The problem is with the growing enterprise data, as I mentioned, probably when we started the application of 1 million records in a day for FX, it increased to 5 million, and equities, it increased again to 6 million, and fixed income, it increased. Because of the growing enterprise data and adding more sources, what? Probably now the marketing team has come up with, now we have to add one more source, right? They will say add one more source, right? And add one more source, right? Um, New source, and they are asking for more and more sources to be added because they want to do it from a centralized place for other asset classes as well. And apart from that, data also keep growing. So we are not able to meet the our SLAs because we are not able to process the data within 5 hours. Because what you can do here is probably we can increase RAM, you can increase the processor. Now it's basically in data warehousing application. It's called vertical scalability. What you can do is if it's not performing within 5 hours time, we can increase your RAM, you can increase number of processors, but after a certain point of time, it doesn't scale anymore because vertical scalability is not easy. So we hit a ceiling where we are not able to process the data within 5 hours. So the problem number one here I'm putting, what? Um, Not able to process within 5 hours due to growing enterprise data and adding more sources, right? Right? Because we have only around 5 hours time. So what we need an alternative framework. Right? What you need is basically one of the solution is need alternate framework for faster processing. Right? This is the limitation, one of the limitations in data warehousing applications. With the growing enterprise data, we are not able to process within 5 hours and not able to meet the SLAs of providing the reports by 1:30 a.m. Right? That's the problem number one. Right? Problem number one. Let me write it down. Write it down here. Primarily, it's a processing. Right? And other problem that's processing problem. And what you do is usually, right? Let's say when you start the application, right? We have 3 years worth of data, and as you progress, probably your enterprise data is keep going because you are keep accumulating the new data that is coming in. Now we have 6 years worth of data. After that, we have 7 years worth of data. And after that, our systems are not able to handle the growing data because initially we have 3 years historic data. Now it's accumulated to 7 years historic data. So after that, probably start negotiating with the business users. Now we cannot keep any more 7 years worth of historic data because data is growing. And initially, when short application of 4 years data, short data, but now it's keep growing. Our systems are not capable to handle these huge volumes of data. I probably try to increase the disk, but again, because of vertical scalability, we will hit a point where we cannot scale anymore. So start negotiating with the clients, but and basically, we cannot keep the data anymore, historic data, and start negotiating. We can keep only 5 years worth of data. Why we are doing all this? Because our systems, data warehousing applications, traditional data warehousing applications, are not capable of holding huge volumes of data, right? And because another problem is storage problem, right? Problem number two is storage. And here I want to give little more here as well, right? And um, probably it's there are other limitations as well. Storage problem. There are other storage problems as well. Example, right? When here they are giving a flat files, right? At the end of the day, they are flat files. Right? Flat file one, flat file one. Let's say. Yeah, similarly, every system is giving file, right? And every day they will giving the files, right? Probably this file as, let's say, 15 columns, right? Let's say this column has 15 columns, right? Again, this, I make it simple, again this has 15 columns, right? This is basically called raw data. What is coming from the source, it has 15 columns. But when you started your application, probably we don't need to report the data with all the 15 columns. So what to do is, from source one, I need only 10 columns. From here, probably only 8 columns. Right? So on and so forth. So even the source is giving all the 15 columns, right? Of course, we'll keep it in the staging area, we will keep with all 15 columns. But when you move the data into consolidated tables, we will keep only what is required for your reporting. So these staging tables again will keep it for 3 months. After that, we will purge it. Even the files, these files keep accumulating, right? And every day we get the files, we will keep it only last 3 month files. After that, we will purge into a different location. Right? Why you do all this? you don't have enough storage. Right? Just I will repeat again. Probably these flat files will getting the files daily, right? Probably when you have the application, probably in 3 years, we don't keep all 3 years worth of files. We will keep it only 3 months or 2 months. Rest of the files we will purge it because we don't have enough storage. But this data is already accumulated in our data warehousing application, but not with 15 columns, only with 10 columns. Not with 15 columns, only with 10 columns, right? So why you are purging these files? Why you are not keeping 3 years, 4 years worth of files? Because you don't have enough storage. Right? And later, I mean, this head of this head of marketing has come up with a new requirement, and it says now I need 3 more columns which are not captured earlier, needed for reporting. Right? And that is very difficult to do it in data warehousing application, right? Because our data, these flat files are purged, go to a different location. It's very tedious job again to get the data for all these remaining 3 columns which is needed for reporting and doing our reporting again. So this is basically one of the problem. What you call is we cannot explore high fidelity raw data because because what you have is only 10 columns. If you want to do a reporting at later point of time, initially it's not required. Probably down the line, 2 years down the line, if they want to do a reporting on these extra 2 columns, what which is not possible because we have purged our files into a different locations. This is also a problem with data warehousing application, traditional data warehousing applications. I think I've spent significant amount of time to understand the limitations of data warehousing applications. Probably it might be boring, but I think it's worth understanding the problems of data warehousing applications before traditional data warehousing applications before you understand what which framework addresses these problems. So problem number one, problem number two is storage. Right? Storage. That is why we are basically we are not keeping the data, right? We are keeping only 3 months worth of data. After that, we are purging the files. Even we are not taking all the 15 columns. We are getting only 10 columns because storage is a problem here, and storage is a problem. So that's why keeping only 10 columns that are required for reporting. Right? These are the problems for reporting. And also we start negotiating with the client. We cannot keep any more historic data because we don't have enough storage as well. Right? The primary problem, storage problem, and the processing. But let me go to the slides. Right? So archiving equal to premature data death. This is basically original raw data. Right? Whatever the files we are getting from the upstream systems, we are keeping only for 3 months. After that, we are purging. So at later point of time, right, after 2 years, we cannot explore original high fidelity raw data because it's already purged and moved there. So, and we need an alternative framework, right, which where we need not archive the data. Right? This is basically, I think it's clear, archiving premature data death. This example is what we talked about the files. We'll keep it only for 3 months. After that, we'll purge it. After 2 years down the line, if I want to explore the data, it cannot explore the data, right? Because it's already moved to a different purged location. Right? Moving data to compute doesn't scale. This is what the processing problem. I think I've talked in last 15-20 minutes. No? Our SLAs, we are not able to meet SLAs because of the growing enterprise data. By adding more sources and from the same source as well, the data is keep growing. because enterprises are capturing the data which was not captured earlier. Probably, for reporting needs, we start capturing more data. Right? So we are not able to meet the SLAs, and these are the primary limitations, and these limitations are due to storage problem and a processing problem. Right? Within traditional data warehousing applications, only you can do scale it vertically. So we can increase the RAM, you can increase the number of processors. At some point of time, we will hit a ceiling where we cannot handle it anymore. Right? And this is the two problems, and processing and storage. And we need basically an alternative framework, right, to handle right to handle and growing enterprise data, right? Addresses, let's say addresses, processing and storage problems. Okay, then good. We will talk about this and how Hadoop addresses these problems in part 2, and but just let me quickly cover the other topics. These are the problems, and right, as I mentioned, so data is keep growing. So probably it's basically a theory only, probably how the data is keep growing. So the social networking sites are generating huge volumes of data. Even you and me also are creating more data, generating more data by operating uh, a phone, using YouTube, using um, Facebook, right? So New York Stock Exchange, if you see New York Stock Exchange captures more than 1 terabytes of data every day, right? And other applications are sensors. Sensors also generate huge volumes of data, right? And social networking said Facebook captures more than 500 terabytes of data daily, right? So now and YouTube users uploads more than 72 hours of video every day. So data is keep exploding. So we need an alternative framework to address the growing data, right? That's what probably next slide also. And now not only structured data, because you start uploading now videos, image files. This is unstructured data which is huge in size. Now because of this unstructured data as well, the data is keep growing. Right? This is more of data is keep growing because of we start using social networking sites, and uh, enterprises now start capturing the data which was not captured earlier. Right? What NYSE stock exchange captured more than 1 terabyte of data, right? And we'll talk about just park it here. Whatever the problems, storage and processing. We'll talk about what is a big data. Big data is not technology. Big data is because of everybody start generating the data. Data is keep growing like Facebook, Twitter, YouTube. So we are generating huge volumes of data. So let's quickly go through what is big data, right? So big data, IBM definition for big data is volume, right? Huge volume of data. Probably what you have is traditional data warehousing applications. Usually the biggest data warehousing applications they have worked, we have until 3 terabytes of data, right? 3-4 terabytes of data. So probably anything more than 10 terabytes, generating the data, probably probably more than 3-4 terabytes, we can consider as big data for an enterprise. Probably banks and all don't generate huge volumes of data, right? But social networking site there's no end. No, they will be keep generating huge volumes of data as we covered in here, right? And now the banks definitely will be start capturing the data which was not captured earlier because of that only, because of the limitations of data warehousing applications. Even there is a requirement, there's a this thing, they cannot handle more than this capacity. So because of these Hadoop tools, they might be capturing huge volumes of data, I think, going forward, right? So huge volume of data, and velocity. Now, data is keep coming with a velocity. It's not like that I will get the data only once in month, right? I will get only first of every month, but again I will get data again the next month first one. It's not like that. Data has to keep coming with a specific velocity. So variety of data, no? Not only structured format, tables, columns, also unstructured data, semi-structured data, image files, audio files, video files, and veracity. Veracity is basically data in doubt. Whatever the data that is coming in, it's not clear. It's case with most of the data warehousing applications, so that is where our data cleansing. In part of ETL, you always have a data cleansing. So definition for big data is not a technology. Big data is the when all these criteria are met, we'll consider your data as big data. Huge volume of data. Data is keep coming with velocity and variety of data and veracity. And again, data in many forms, I think we discussed a variety of data. Structured data is like tables and columns. Semi-structured data, XML files. XML files is the mostly used format to exchange data between different applications. Unstructured data, audio files, video files, image files. All right? So we need an alternative framework which addresses the problems what we have discussed earlier. Primary problem is storage and processing. Because of that, we are doing archiving data. We cannot explore original raw data from operational stores. It cannot scale. So we already discussed earlier, right? And so we need an alternative framework to handle limitations and to handle the big data, what we have discussed, the definition for big data, right? We need an alternative framework. So Hadoop addresses this problem, right? We'll talk about in detail how Hadoop addresses this problem. But before that, we'll talk about history of Hadoop, right? Basically, Apache Hadoop, MapReduce and HDFS components is basically inspired by Google white paper, right? So they have released a white paper how they are storing huge volumes of data and how they are processing the huge volumes of data, right? I think we need not discuss more how much volumes of data Google stores every day. So it's a huge volumes of data, and now they are storing the data in what is called a Google file system. It's a distributed file system, and they are using MapReduce to process the data stored in Google file system. So they have released a white paper, and based on this white paper, duck cutting has invented Hadoop, right? And in case of Google file system, he named it Hadoop distributed file system, and use MapReduce to process the data within HDFS. Yeah, so inspired by Google white paper, duck cutting invented Hadoop, right? He named file system as Hadoop distributed file system and for processing MapReduce. And the name Hadoop has come, so when I think his own words, it's difficult to name a probably product, any software product. So his son, in a blue moon, he called his son as a yellow elephant. He called that elephant as Hadoop. So he has given the Hadoop name to the product, software product. So it's named after his son's toy elephant. Yeah. And before you, I think, to understand better Hadoop, I thought no, we should know more about a cluster. Cluster is basically a set of computers. If we got a chance to visit data centers, in a data center we have many racks. Right? This is a rack, and each rack is a stack of computers. And what you have is one monitor. If at all you want to view files in a specific CPU, we will plug the wire to the CPU and check the files. And sorry, um, yeah, and basically we will use it for parallel processing, load balancing, fault tolerance. We will use the clusters, and we'll talk more about Hadoop distributed file system, um, and other things in the next part two of the video, right? And yeah, let me go to it. And what you have covered so far is probably talked about what is an operational reporting and analytical reporting. I think that's clear. I hope. And what are the limitations of data warehousing applications and a need for an alternative framework. So Hadoop addresses these problems. So probably we'll talk about in detail how it addresses problem in a different video part two, right? And primary the problem of data warehousing application, one is storage and processing and the history of Hadoop, right? All this is covered in part one. In part two of the demo, we will cover how Hadoop addresses the problem of storage and processing. So I hope you enjoyed the session. Thanks for your time. Probably we will meet in probably part two of the demo, I think, which is more of a Hadoop storage and processing. We'll talk about more in detail Hadoop storage and processing. Right? And again, thank you very much.